In this video, I'm going to show you how to get measurements off an oscilloscope by reading the number of divisions in the dials. Okay, so notice we've got a trace in here. Notice that the trace is nicely centered about the zero line there. That's zero voltage. Okay, you can check that zero voltage. You flip this thing to ground, right, and then move this position up and down so that it reads zero. And then if you flip it back to AC, if it doesn't center itself nicely, like this seems a little bit low, you might move this position knob and move it so it's centered up and down, okay? Now, there's two things we can read about this, right? We can read the period, which is the amount of time here. That's our period, okay, from peak to peak. Now, when I set up this trace, I used this knob here to move the trace to the right so that I put one of the peaks right on top of this one, right? And then I'm just going to measure the divisions to this next one here. Okay, so let's look at the period of this. And that's just the time from peak to peak, right? I see that this is 1, 2, 3 divisions, exactly, because, well, I set it up that way, right? So it's 3 divisions. And then let's look at the setting here, right? Notice that that is at 0.5 milliseconds per division, right? So 0.5 milliseconds per division. Okay, so the period is going to be 3 times 0.5 e minus 3 seconds, right? Because that's milliseconds. It's just that times 10 to the minus third, right? So if I go 3 times 0.5 e minus 3, I get that the period of this thing is 0.0015 seconds, or 1.5 milliseconds. Okay, so that's my period. Okay, that's the time. Now the frequency, by the way, is just 1 divided by that. So if I go that to the minus 1, I get that this is actually 666 hertz or something like that. Okay, so the frequency is 1 over the period is 1 over 0.0015, which is actually the beast. It's 666.666 hertz. So there's two things we can get, really, is we can get the frequency, we can get the period, okay? And then the peak voltage is going to be this guy here, okay? Right there. Let's measure that peak. Well, it's 1, 2 divisions. Notice that each division on the vertical axis is 2, right? So the voltage, the peak voltage, or V naught, right, as we do in the IB thing, right, is going to be just 2 times 10, or sorry, 2 times, 5 volts per division, okay, because it says 5 there, so 2 times 5 is 10 volts. That's the peak voltage, okay? All right, let's look at another one here. All right. Let's find the period of this guy, and let's find the peak voltage, okay? The period is the time from here to here, okay? So that looks like it's 1, 2, 3.5. Looks like 3.3, I'll say. 3.3 divisions. And then each division is 1 millisecond. Times 1 times 10 to the minus third seconds per division, right? That's what 1 millisecond means, right? Okay, so 3.3 times 1 times 10 to the minus third is going to be 3.3 times 10 to the minus third seconds. That's our period, okay? And then if I go 1 over that, right, so 3.3 times 1 e minus 3 gives us, it's 0, it's in seconds, it would be 0.0033 seconds. And then if I raise that to the minus 1, if I find the reciprocal of that, the frequency is about 300 hertz. I get 303 hertz. Right? And remember, frequency is 1 over period. Okay? All right, let's find the peak voltage. Notice that we're at 2 volts per division here. So it's 2, 4, 6. So it's going to be 3 divisions times 2 volts per division is 6 volts. That's my peak voltage. And you could argue that we have some sig figs here, like we could say 6.0 maybe, right? Okay. Yeah. Yeah. All right. Let's look at another one here. I got a couple more. Obviously, you can just stop listening when when you got this. Okay, so let's find the period. The period is the time from here to here. That's 1, 2, 3, 4, 5 divisions. And this is 2 milliseconds per division times 2e minus 3 seconds per division. Okay, and that's going to be, let's see, this is higher mathematics. I got to do this with the calculator. 5 times 2e minus 3, that's 0.01. So the period is 0.01 seconds. The frequency is therefore 100 hertz, right? Yeah, that makes sense. 1 over 100th is 100. Okay, so that's our frequency. And again, the formula for frequency is just 1 over period, right? All right, let's find the peak voltage. So we are at 1 volt per division. Do you see that? So 1, 2, 3, right? There's 3 divisions there. So that is 3.0 volts. That's easy, right? All right. One more example. This one's going to be, the last example is the most dodgy. Like, whoa, it doesn't come out. It's like, whoa, it's not even. Okay, okay, so our period, let's find our period. And that's the time from here to here. Right, what is that? Is that a third of the way across? Let's say it is. So 1, 2, 3.3. So 3.3 divisions. And then how many seconds per division? 2 milliseconds, right? What is that? 3.3 times 2 times 10 to the minus third is, the period is 0.0066 seconds. Okay, the frequency is just 1 over that. So raised to the minus 1. And that's 151. I think I was trying to make it 150. 151.5151515151515151515151. Anyway, hertz. There we go. All right, and then what is our peak voltage? Well, we're at 1 volt per division. How many divisions? 1.8, looks like, doesn't it? Is that 1.8? It's hard to say. Yeah, I think it is. It's like one of those little tick marks. So the peak voltage is 1.8 divisions times 1 volt per division. So it's 1.8 volts. All right.